These are going to be just three density examples. So hopefully we've talked about density a little bit in class. Probably shown you the egg in water and probably the ice floating in things. So density can be a little bit complicated because you think things that are heavy have a lot of density. But a ship can weigh 5 billion pounds and still float on water. Okay, so just because things are heavy doesn't mean they have a lot of density. So we measure density in a certain amount of weight or mass per a certain amount of volume. So a lot of times it's per cubic centimeter. So here's a cubic centimeter. So we say, okay, the density of water, every piece of water this big, 1 cubic centimeter of water, is a gram. For air, a piece of air this size is going to be way less than a gram, so it's way less dense than water. This is a piece of aluminum, so this is going to be approximately 3 grams for every piece this size. So we want to know if we would take a chunk off this big, what would the mass of it be? We don't have to use cubic centimeters. We could do it in cubic feet. We could say, here's a cubic foot. Here's 1 cubic foot. We could do densities in this. Well, if we look here, the density of mercury, so if we have a box this big filled with mercury, it's 849 pounds. That means its density is 849 pounds per cubic foot. Aluminum is 165 pounds per cubic foot. So we can compare which of these is more dense if we're measuring the same amount of space of each one. So we can get how much weight or mass there is per that much space. If we look at the air compared to O2 compared to CO2, that's how many pounds they are per cubic foot. So CO2 is the most dense of these three gases. Obviously, these three gases are way less dense than those things right there. So here's the three density problems again. So we need to know what is the mass per amount of volume. Typically, we're going to do these in grams per milliliter if we're doing a liquid, or grams per cubic centimeter if we're doing a solid. Remember, a milliliter is the same thing as a cubic centimeter. Here's a cubic centimeter. If we could open this box up and pour water into it, we could get 1 milliliter of water into this. So I'm going to do, this is question 4, letter A, page 6 of your notes. Okay, 4A. And it says you have a cube like this that is 3 centimeters on a side, so bigger than this one, and has a mass of 9 grams. We want to know the density. Well, we know the mass is 9 grams. That's our mass. We need to know the volume. It doesn't give us a volume. It tells us that the cube, my terrible drawing skills, the cube is 3 centimeters on the side. So it's 3 centimeters on that side, 3 centimeters there, and 3 there. You should know that volume is length times width times height. So 3 times 3 times 3 is actually not 9, 27 centimeters cubed. So that cube would be 27 of these. So the volume is 27 centimeters cubed. 9 divided by 27 is 0.33. Our label is grams per cubic centimeter. So whatever object that is, it's saying that every piece of it this big is 0.33 grams. That's less dense than water. Water would be 1 gram per every cubic centimeter, so that would be floating on water, less dense than water. Letter B there. Letter B wants to know what is the mass. So if I write my equation here, we're solving for mass. So we should have the density and the volume in the problem. It's a liquid. The density is 5.1. We know we're trying to find the mass, so it should give us a volume. Volume is 25 milliliters. Well, it's this many grams for each milliliter, and we have 25 milliliters. I tend to put this over 1 and cross multiply and divide. So remember, cross multiply where there's no variable. 25 times 5.1 divided by 1. So our mass is about 128 grams if we had 25 milliliters of it. Obviously, if we had more of it, it'd be a higher mass. Letter C there, again, density equals mass over volume. This one is asking for volume. It tells us the density is 0.95, so we put that 0.95 out front. Again, I put that over 1 equals, it gives us a mass of 100 grams, trying to find the volume. So the density is given to us, the mass is given to us. Again, cross, multiply, and divide. Put that over 1, so I want to cross multiply this direction and then divide by that. So I'm taking 1 times 100 divided by 0.95. So always cross multiply where there's no variable. Well, 100 divided by 0.95 is actually 105. So it's 105. In this case, our volume is in milliliters or cubic centimeters.